All right, here we go. We are talking about a thing. We talked about, what was the word yesterday we talked about? Yeah, surface area of what, though? Prism, okay? Now, this one's not a prism, because remember what the prism had. The prism had the top, the top and the bottom were exactly the same, all right? You had two bases, didn't you? You had one on the top, one on the bottom. So you had a base, and then the sides just went up. They went straight up. They went perpendicular to the base. Everybody with me on that? That was a what? Prism. Now, unfortunately, these two words start with the same letter, and every once in a while, I'll probably just tell you right now, I'll probably get the two words mixed up. Even though I do know the difference between the two, I just misspeak. Is that right? I misspeak, right? Sometimes, and so anyway, but this right here, it's not a prism. What does it look like? It looks like a pyramid. So we are going to find the surface area. The surface area of a pyramid. Now let me just talk about the pyramid for a second. What it does is this. You've got a certain base. Now you could have a rectangular pyramid. You could have a triangular. You could have all kinds of different shapes on the bottom to have a pyramid. All right, but what happens to the pyramid? The sides don't just go straight up and then straight across. In fact, you only have one base. See that? You only have, oh, I'm writing in white, so that's not going to show up on white, is it? Let's go this dark blue. All right. So look, you just have this one base right here, and you don't have a base on the top. Why? Because look what the sides do. They all slant, don't they? They all slant up to a common point. Everybody see that? So that common point right there is where all those sides end up. Now, you do have a height to this thing. Where is the height? The height is not down one of the sides. The height is from the top. We don't say straight down. What do we say? Perpendicular to the base. So the height is still perpendicular to the base, but it's not down one of the sides. It's not the length of one of the sides of this pyramid, is it? I always think of this. If you're at the top and you want to slide down, here's the red line right here. Watch. If you wanted to slide down, slide down like this. That is not the height, is it? All right? This is the height. If there was a hole up at the top and you were to just drop straight down on a rope or something, that would be the height. All right? I'm thinking Indiana Jones. You guys ever watch Indiana Jones? That was really big when I was in high school. You know, for you guys, it's like this old movie. But I remember when it first came out, we couldn't wait for the next, movie to come out and that kind of stuff. And I remember the one time, do you remember the one where they opened up that cave and they went down and he dropped in and there's snakes all around him? He's like, oh, snakes, I hate snakes or something. Was that the first one? Okay, that was pretty cool. So that's what I think of when I think of this pyramid. I think him being at the top, lowered down by a rope, and there's a bunch of snakes down here at the bottom, okay? So there you go. So it's perpendicular. This height is perpendicular. But look at the red one, though. Let's talk about the red one. That's also a very important, it's a very important length that I need to know. We call this, they call it L, and most books do, and this book does as well. The height is H, by the way, all right, so you see it right there. L is called the slant height. So the slant height, that does go down one of the sides or one of the faces. We call these sides of the pyramid. We call it a face of the pyramid. It goes down one of the faces, but it doesn't just go down anywhere. What does it do? It's also perpendicular. Do you see that side right here? If I was able to tilt it and put it up, this would be perpendicular. Do you see that? That red line would be perpendicular to that side of the base. Does that make sense? Yeah. Not necessarily, because if this was a regular polygon and the top of this pyramid was above the center of it, then yes, it would. Okay, and that does happen every once in a while, but it doesn't always have. This doesn't always have to be right over the top of it. But if this was a regular polygon, and I'm not sure how they say that. Yeah, if it was a regular pyramid, then absolutely, the bases would all be equal to each other, and the top of it would be right above the center. So if I dropped it down, that would be the center. So let's say this kind of looks like it's a regular pyramid. So if it's a regular pyramid, you guys watching, right? You understand what a regular pyramid is? Because that's really important, because that's going to help you find some stuff. If this is a regular pyramid, then all four of these sides are the same. Now, it doesn't have to be just four sides. It could be a triangular pyramid. It could be a pentagonal, right? The bottom could be a pentagon. It could be a hexagon or whatever. You could have all kinds of different shapes here. But if it's a regular pyramid, then the top of it, if you drop it straight down or perpendicular, it's going to hit right at the center of that polygon at the bottom. So if that was true, then this slant height right here, it would bisect. So they would tell you, yes. Yep, they would tell you that it's regular. So if it's regular, yeah, absolutely, this would bisect this thing right here, and it does bisect the angle at the top as well. Does that make sense? So a lot of these, they will say that it's a regular polygon, or regular pyramid, I should say. So that's definitely important to talk about. But L is the slant height. That looks a little ugly, but L, we use the letter L for slant height. What is that? It's from here, and it's down the face, perpendicular to one of the sides. Does that make sense? Okay, so you just have to basically know what these letters stand for. The L is a little different. We didn't have a slant height in the other one, right? Because all the heights were the same, because they just went straight down. This goes down at a slant, doesn't it? This side is it's tilted, all right? So it goes down at a slant, and that's why they call that the slant height. We good? All right, we need a formula though, don't we? Now, are we going to do like the top and bottom like we did before? No, because if we're going to do surface area of this thing, there's only one base, right? But we still have to find the area of the base. So if we're going to find the total surface area, I'll write it down here, of a pyramid, okay? We're talking pyramid here. If I want to find the total surface area, what I'm going to do is I'm going to find the area, I'll write it all out, the area of the base plus, what do you think? All the other, what's that? All the other what? I've got the area of the base, all the other sides, or the faces, okay? And yeah, they're going to call that, let me make sure that this book does call that. Yeah, I don't see where the book calls it that, but we'll call it that anyway. I'm looking, sorry. Yeah, we'll call it that anyway, okay? We kind of are familiar already with the lateral surface area, so we're talking about all these different faces. So the lateral surface area is all those different faces. Let's think about how we're going to do this. The area of the base, it all depends on what kind of figure. So you're not always just going to say length times width or anything like that, or base times height. It could be a triangle, it could be a quadrilateral like it is here, or a parallelogram. It could be a pentagon, it could be a hexagon, it could be whatever. All right, so depending on what kind of figure, that's what you're going to do there. You're just going to find the area of this base, plus the lateral surface area. Okay, so how in the world do we do that? This time, it's not just the perimeter of the base times the height. Okay? Let me see something real quick. Yeah, they do call it the lateral area, actually. Okay? And here's what it is. This is not a rectangle like it was before. Remember all the sides on that prism were all rectangles? So we just said the perimeter of the base times the height, base times height. But this time it's not just base times height. What is it? It's a triangle, isn't it? So what do you think it's going to be? Let's just do this. Let's just find the area of one of these triangles right there. What would it be? It'd be 1/2, right? This base, right, times, now what would the height be? It's the slant height. That's right, because we're just taking a look at this face of the pyramid. You see it? So if I look at the face of the pyramid, what is the height of this face or this triangle? It's L, the slant height, isn't it? So it's 1/2 this base, or one of the sides, okay, times L. But we're going to do that how many times? As many triangles as we have. In this case, 4 times. What if we had a pentagon? We'd do it what? 5 times. So what would it be? It's 1/2 the, let me see what they say here. Yeah, I'll use P because we're going to do the perimeter of the bases. Do you see this? The perimeter of the base. Because if I have 4, what do? It's 4 times whatever the base is, right? If there's 5, if it's a pentagon, it'd be 5 times whatever that base is. So that's really the perimeter of the base. So I'll just use P for perimeter of the base. So it's 1/2. This is the base. This is actually all the bases added up times the what? Times the slant height, which is L. So that's a little bit different than we did on the prism. So here it is. It's still the area of the base plus the lateral surface area. But in this case, how do we find the lateral surface area? It's 1/2 times the perimeter of the base. Okay? So if this is the base right here, it's 1/2 the perimeter of the base times the slant height. That's new right there. We didn't really do that yesterday, but it's very familiar. It's very close to what we did yesterday, because what did we do yesterday? We said it was the perimeter of the base times the height, just because everything was a rectangle. This time it's 1/2 the perimeter of the base times not just any old height, but which one? The slant height, because this thing is slanted now. It's not just straight up and down. So that's how you find the lateral surface area. If there's 4 sides, right? So let's stick some numbers in here, okay, just for fun. So let's say the slant height is, I don't know, let's give some weird number. Let's say 7. All right. And let's say the base is 6. Is that all right? Let's say this whole base is 6, and I believe that's all you're going to need to know, isn't it? Yep. And it's irregular. Okay, we're saying that it's regular. All right, it's a regular pyramid. So that means if this is 6, what's true about all the other sides? It's 6. So what's the area of this base? It's 6 times, is it the area of the base? Right, because we're doing the area of the base plus, right, 6 times 6, correct? And that's 36. That's just the square, right? That's all I did was find the area of that square right there, all right? Plus the lateral surface area. So I got to find all these triangles, all 4 of these triangles. So what do? It's 1/2, because it's a triangle, that's why I put 1/2. The perimeter of the base. That's right, it's 6 times 4, isn't it? You see why it's 6 times 4? Because there's 4 sides. What if this was a hexagon? It would be what? 6 times 6. What if it was an octagon? It would be what? 6 times 8. Make sense? Okay. 6 times 4 because it's a 4-sided figure. It's quadrilateral. All right? Times what? The slant height. What's the slant height of this? It's 7, right? Plug all that in. I'm not going to do all this, but plug all that in, and then you've got your answer.
Wait, did you hit the first 6 times 6?
Because that's the area of the base. See? Area of the base, I put that little squiggly thing. Okay, 6 times 6, because it's a, and I shaded it in, right? Remember, it's regular, so it's a square, isn't it? All right, it has to be a square if it's a regular pyramid, because if it's 4 sides, if all the angles are equal and all the sides are equal, it's got to be a square. So it's base times height, 6 times 6, right? This times this. Now, this doesn't look like it's a right angle because it's drawn 3-dimensionally. You understand that, don't you? All right? People look at this and say, oh, that's not a right angle. Well, it actually is if they say it's a regular polygon. All right. And then you just stick all those numbers in, and then there you go. You got the surface area. You can do those numbers on your own. Make sense? Let's do one more. Okay, this is not a pyramid, but we call this thing a cone. Kind of looks like an ice cream cone upside down, right? Pointy side is up, right? You put the ice cream in here, but they call this a cone. So basically it is a pyramid, except what's the base of it? It's a circle, all right? So we give it a special name, just like we did circumference and just like we did a cylinder. We call this thing a cone. Now look at its slant height. Kind of makes sense, doesn't it? The slant height is from the top, and it's straight down like this. Now remember, this is curved all around, isn't it? It's nice and smooth and curved all around. It's got a height. The height is from the top, perpendicular to the base. It also has a radius. So let's think about how we're going to find the area of this. Now the lateral surface area may not be quite as easy for you to figure out, but I'll just show it to you. So what is the total surface area? I'll just put SA for surface area. Well, first of all, it's the area of the base, right? Plus the what? The lateral surface area. Now, I'm going to give you a formula for lateral surface area. First of all, though, we know the area of the base. It's a circle. So what's the area of a circle? It's just pi r squared. Okay, so if you know r, you can find the area of the base. That's not hard. Plus the lateral surface area. Okay, the lateral surface area is pi RL. Pi RL. Okay? Yep, it's pi r times the slant height. L is the slant height just like it was before. And there you go. That's how you find the surface area of a cone. Pretty simple, isn't it? All right? So really, the only thing new you had to really learn is the sides. Okay, that's all the smooth sides. Everything but the bottom. Okay, remember, it's all closed in. When I think ice cream cone, you think it's empty, right? And you put stuff in it. But this is not empty. It's a solid, right? So the bottom of it is pi r squared, and all the sides of it is pi RL. You just have to remember that the lateral surface area of this is going to be pi RL. All right? Does that make sense? Okay. All right. I think we covered everything there. So that shouldn't be too hard. They give you on page 842, they kind of give you a list of a bunch of different formulas, but I kind of like the way that I went through it. So let's do this. Let's do page 843. And let's go 7 to 15. No, let's go 18. Okay, there you go. So it's section 12. What is it? 3. There it is, right there. Section 12.3, page 843. We're doing 7 to 18. We're doing all of them this time. I'm not letting you off easy this time. Okay.